Hi y'all. Hi. Uh, this is a very interactive presentation. Thanks for the intro, Scott, and I appreciate y'all inviting me to do this again. Which means I feel like last time it was pretty good. I'm going to try to recreate some of the magic from last year. Oh, the audio's not good. Y'all, is it like goofy somehow? Like, what does it sound like? Do I sound like? It sounds choppy, staticky, and crumbly. Okay, hold on. Let me fix. We can't have that, chat. Hold on. Okay, how about now? Is it worse or better? Oh, okay. Okay. Oh, right. Jeez. All right. Don't need to tell me twice, y'all. Okay. Well, hello. I appreciate being invited back a second time here. That's great. Yeah. It's Joey B right there. All right. I am the director of baseball analytics at the Cincinnati Reds. I am currently in our spring training conference room. Last year I did it out of our owner's office and I was like petrified the entire time. So I'm pretty excited to not be completely running on anxiety. So that's a big shout out to Sarah Vetter for hooking me up with the conference room for the hour. So today we're going to go through some data visualization. You might know me for my Twitch streams. Does anyone watch? Has anyone watched me on Twitch? Yeah, no. It's okay if you haven't. Like, no one watches it. So I typically cover a lot of data science and sports analytics news on my Twitch stream. I stream basically every day from around 8 p.m. Eastern to about midnight. At spring training, it's a little more complicated since we're kind of doing everything around clock here. But usually in March, we have a game show called Viz Buzz, where I invite data analysts, data scientists, people who are familiar with data and programming, and I challenge them to recreate data visualization in like 30 minutes usually. Last night was our first episode for the season. We did this last year for 4 episodes, so it went really well. But in the vein of the title of the talk, Sliced with SABR, I will do a game show style, but not really. It's not really a game show. I'm just like walking through code and recreating a data visualization. Can I plug the channel? It's twitch.tv/Nick Wan Data Sci, DATASCI. Someone I rated someone once and they were like, "Oh, thanks, Nick Wan Dataski." That's not how either of those things are pronounced. It's Nick Wan Data Sci. So okay, I gotta turn that off too. Okay, all right, thank you. I gotta turn off. Okay, yes. The people find me on the Twitch and then they just start spamming the channel and yeah, things start popping up. But okay, we're good now. Let's go to the coding screen. I gotta figure out where to put chat. Chat, you're gonna be there. How's everyone doing? How's all the presentations? How's David? David's presentation seemed enlightening. Hold on, let me see. Nick Wan _ data sci. Yeah, you need the underscore in there. You're gonna go to like some dude who plays like Valorant or something. I don't know. Okay, I gotta turn it off here too. Okay, turn that off here. Okay. So I'm gonna post this link to this notebook here. Got a link. I'm gonna put this in the chat. So I'm just gonna be working off this notebook. Feel free to copy this. Feel free to save this off. This is all in Python. I'm sure you've had a lot of people do things in either Python or R or Excel or I saw Sean Lahman was on here doing a probably some database expert stuff that goes well over my head. Man, what a treat to have Sean Lahman on doing some stuff here. That's a living sports analytics legend right there. Okay, so we're gonna go. I'm just gonna copy a data visualization from Baseball Savant, and I'm going to use an example with Spencer Steer. Y'all know Spencer Steer? Any Minnesota Twins player development fans in here? So we made a trade for Spencer Steer last season, and sometimes when, like, you know, someone comes to your favorite team, comes to a team that you're working for, you might just get curious and look some stuff up on Baseball Savant. So for me today, whenever the swing take data decides to load in, you know, it's gonna happen soon enough. There it is. I think today I'm gonna try to recreate this data visualization right here, and this is for those wondering what this is. If, obviously, this is a strike zone, and the thing that it is, the page that we're on, it's StatCast swing take. In this zone, you'll see these different colors, which correspond to heart, shadow, chase, and waste. You also see the rulebook strike zone here dotted in green. I hope that is also color line friendly green. But there's a dotted line here that represents the rulebook strike zone. And you can see that the heart of the zone is this area here. Some people call this attack zones. And this is really not just where pitches thrown are called for a very high likelihood of strikes, but it's also where if you swing the bat through this zone, you tend to generate lots of runs. The shadow zone here is that 50-50 area. Again, a pitch thrown in this area tends to have an expected strike rate of 50%, but also this is that break-even point for a batter. Some batters have success in the shadow zone and some batters do not. And in general, a lot of these pitches seem to be outside, and of course 50-50 balls, they might not be called for strikes. So some people consider swinging in the shadow zone as a dangerous type of swing. Then you also have the chase zone. Hopefully that makes sense. That is a place where you be chasing a pitch that's well outside of the rulebook strike zone. And there's also the waste zone. Both if you throw pitches into the waste zone, that is always going to be called for a ball. You should really try not to throw pitches there. And then of course, batters who swing there, that is well outside of any zone that would do high expected run value types of hits. So you should not swing at that area. But we want to recreate this. So we're going to use Baseball Savant data. And I don't know if this is like, I think I did this last year. No one at either the MLB or SABR yelled at me for using Pi Baseball to grab data. So I'm just going to assume that's okay. Oh yeah, that's a part of it. Oh yeah, because I'm sharing this thing. Okay, yeah, sorry, my face was obscured, but now no longer. How's everyone doing? How have the sessions been? Have they been okay? I'm just taking before I started, I made sure to load in the data so we didn't have to wait on a data load, data to be loaded in. So I just made sure the data is loaded in here. They were great. That's good. That's good. They have rate. Wow. Okay, that's good too. That's who was everyone's favorite? What were some favorite things or topics? Even favorite topics. Oh wait, this is Lars Nootbaar. I don't want Lars Nootbaar. Hold on. I gotta change this out. I want Spencer Steer, dude. Okay, I'm gonna change this to Spencer Steer. Hopefully this won't take too long. Shanna smashed it. Okay. Newt, yes. Is he on Team Japan? Did I see that correctly? He's a Team Japan guy. He is? Okay. That's a fun one. That's a fun one. Shanna, everyone likes Shanna. Okay. All right, Spencer Steer Day. We do have, okay, I queried this right. If anyone was wondering about these numbers right here, this is what we call a BAM ID. So on anyone's page, if you end up Googling, hold on, let me make sure I do this in a safe way. MLB Spencer Steer. If you end up Googling a player, and on the MLB site, you see their name, Spencer Steer, and then 6 numbers after it, 668 715 for this player. You will end up getting their what's known as a BAM ID, the MLB Advanced Media ID. And so that's what we're using here, 668 715. So that's their unique ID. And I'm just taking data from what I believe is the beginning of the 2022 season, all the way to what I believe is the end of the 2022 season. I just put really big, wide numbers on it. Obviously, March 1st, they would still be in spring training, and November 1st, I believe there's probably some sort of parade happening for a team. But this should capture all the regular season. So Lemon was great. That's good too. That's good. Also, thanks for all the follows. I appreciate that. So we loaded in the data. The data looks like this. This is also the same if you go to StatCast, to the Savant site, and then if you go to, what is it, StatCast CSV, StatCast CSV search, yes. So you can actually download just data straight from the Baseball Savant website. So if you like search for games, you could actually end up downloading a ton of data for yourself. There are, of course, packages that allow you to do this as well, like PyBaseball. I use PyBaseball just because it's easier, but easier for me. But for those who are maybe not familiar with Python, you could actually do it from the website as well. So I have the data loaded in now. The first thing I want to do is just explore the data a little. So we see all these different columns. I could actually put in columns here just to see all the different columns of data that we get from Baseball Savant. You can see we have pitch type, we have the release speed of a pitch, release position, X and Z, Z being from the floor to the ceiling. When we're talking about X, Y, Z coordinates, X would be like left to right, like third base to first base. Y would be from home plate out to the outfield, and then Z is from the floor to the ceiling, or from the ground to the sky if you have an outdoor park. I ran the gather data, but it's not showing up. I don't know, try again. You might need to install the package, but all of this should run because I just ran it. This is the same notebook you're using. So you could also see here that in terms of plate location, there's like plate X, plate Z. And plate X, plate Z, if we take a look at plate X and plate Z, and we just have a sample, let's just take a sample of like 10 rows. They give you these locations, but they're in these numbers, and these numbers are actually in feet. And these are, fractions of feet. And this doesn't necessarily do us too good when we're trying to recreate, where it's, here it is, this, because we really need these bounds, right? So we need to tell our graphing program, whatever we're going to use, to put these bounds in, because if we just plot a bunch of pitches, it's going to look like, it's going to look like nonsense. Actually, we actually got to do that. Hold on, we got to load in a few different things. We got to import, we got pandas as PD. That's our data frame program. Let's go NumPy as NP. That's for numerical stuff. Let's go import matplotlib.py plot as PLT. That's a plotting library. And let's also import Seaborn as SMS. This is also a plotting library. So these two things will help us plot. These two things will help us do stuff with the data. So if we end up plotting all of our pitches, let's just say scatter plot. SDFX, we could call it this plate X, and then Z, Y equals plate Z, and then we'll plot this dot show. You can see here all those pitches in this data frame. These are all the pitches Spencer Steer saw in here. So all these pitches, we need to translate that into runs in these different zones. You can see that there aren't scatter plots in here. And we can also do like other fancy things. So I did this last year. I'll do this one time today. And let's see if we go pitch name. Let's do pitch name. That way, for those who are not so familiar with pitch name shorthanded abbreviations, you could actually see, you could actually get like all the different pitch types that were the pitch type that was thrown, where it was thrown, and the name of it right here if you wanted to. But this is just an example of like plotting something pretty simple, just a scatter plot, taking the data, running a couple lines of code. But really we want to plot this. So let's take the first thing we got to do is label these attack zones. So let's do some data creation. We're going to create a column and we could fill it with just nothing. We'll use NP NaN, not a number. And when we set that equal to this, that will give us attack zone. And if we look at just the top part of our data frame, you could go all the way to the right where we make a new column here. And that new column says attack zone, but there's no numbers in it. It's as if we asked it to do that. That's good. This is excellent. So next thing we want to do is we want to outline what this zone is, right? What this area is, and I believe Tom Tango has some sort of attack zone thing that he. Well, let me see. I'm trying to bring it up while talking, and I'm not good at that. But I think Tom Tango actually has exactly what I need here. This is strikes. If I bring up this website, yes. So Tom Tango has outlined this on his blog. This is sort of the different zones: heart, shadow, chase, and waste. And he has sort of the dimensions of them. So we can actually just like convert these inches into feet and then start plotting these things. So I'm going to post the link of this up here in the comment section for those who are following along in the notebook. So this first area would be from negative 6.7 inches to a positive 6.7 inches. So that's about a little over half a foot. And then you can see that for the shadow zone, negative 13.3 inches to 13.3 inches. The chase zone is this large behemoth of an area. And then the waste is everything else. I will say I have the numbers to do this, so I'm actually just going to steal from myself. That way I don't have to put everyone through having to do this, having to take a calculator out and do this by hand. But for plate X, we're going to go between the values negative 0.558 to 0.558. Remember, a little over 6 or a little over half a foot. This is measured in feet. We're basically doing a conditional statement here. So I'm filtering my data and I'm looking for data that is specifically between plate X, this value, negative half a foot to a foot, to positive half a foot, sorry. And then we're also going to look at the Z, which is 1.833. It's as if I'm looking at these numbers from a different page, to 3.166. And if you can see that here, that is also 22 inches to about 38 inches. Chat, everyone's like pretty quiet. I feel alone right now. Is everyone there? Everyone's just hanging out? Everyone, what WBC team are you rooting for, chat? What's your team? Who are you rooting for, y'all? Zach Adams is here. Welcome, dude. USA. Hell yeah, brother. Canada. Okay. Just rooting for Trout versus Ohtani. Okay, that's good. That's solid. Korea. There you go. That Ko guy actually had a pretty good outing. The DR. That is, I think that's the team to beat. They look stacked. Israel. Oh yeah. Our new assistant pitching coach, Alon Leichman, he pitched for Team Israel, I think, last WBC. So we have this area here, and now what I want to do is anything in this area I want to label heart. Okay. So now if we look at head, you can see that some of the zone is now going to be tagged with the word heart. That means this pitch was thrown in the heart. We could also just kind of start putting together what the data visualization might look like. So if we have, say, let's see, how do I want to plot heart? Let's just do a scatter plot again. Let's take the same scatter plot and now do it with pitch instead of pitch name. We'll say attack zone. And then now these are all pitches in the heart. Notice how there's a lot less pitches than here. That's because all of the other data is null right now, right? So because it's null, we got to fill in all the other attack zones. So let me do that real quick. But this is how you conditionally cut through data and then add a label to it. There are probably better ways to do this, not gonna lie. But this is the way that I'm gonna do it because it worked for me on stream not long ago. So I'm just gonna copy and paste. Actually, I'm just gonna, okay, screw it. I'm just gonna copy and paste a bunch of code. I'm not gonna lie to y'all anymore. I'm just gonna copy and paste a bunch of code now. But it's the same thing we did before. So we're looking between a certain area of pitches. Now, someone out there might say, well, if you're looking in a bigger box, right? If you're looking in, say, the shadow zone, and you say, well, I want the pitches between here and here and here and here, wouldn't that also capture the stuff in the heart? You're correct, it would, which is why, oh God, I pressed the wrong one. It's okay. We are also going to exclude anything in previous zones we've created. So this little tilde here, we're saying, look for pitches within plate X, plate Z in these areas. And then let's also exclude anything in this case, the heart. And then we'll create the shadow zone. And then again, we'll do that. We'll look at a bigger area and we'll say, let's also exclude, use this tilde, exclude anything in the attack zone that says heart or shadow. And that will get us chase. And then because we're doing all of this, we need one more thing here. There is a shortcut to this, but I won't show you the shortcut. That's bad coding practices. I'll do it on my stream, but I won't do it here. We'll fill NA with waste. So anything that is not labeled anymore, we'll fill it with waste. So now if we run this code and we look at the head here, the top of this will have chase, waste, heart. And if we take a random sample of data, let's sample 5 rows. You could also see we're getting that for all pitches, heart, chase, waist, the shadows in this one. So now when we plot this with attack zones, we're now going to get all the pitches again, but we're going to get them with the heart, the waist, the chase, and the shadow, right? Wife is from Brazil, so they're my second team now. Mexico for Jose Carlos. Okay. I think one of our pitchers, Luis Sessa, is pitching for Team Mexico. So we can see here, now it doesn't quite look like this yet, but we're working our way there, chat. All right, we're working our way there. But you can kind of see here are all the pitches in the heart. Here's all the pitches in the shadow. The green would be the chase, and the orange here is this like yellow. What is this? Like a burnt dry leaf. What is this? What is this color? Wait, this would all be pitches in the waist. So, okay. Let's also make this a little bigger for y'all to see, because I think maybe this isn't too large. So I'm gonna make a figure. We're gonna say PLT figure. Let's just say the figure size. Fig size equals Yankees legend Luis Sessa. There you go. This says 8:8. Let's make this 8 by 8. And then everything else here, we'll set this equal to figure now. So this should be a little bigger. Aha. Oh yeah, bigger, y'all. Okay. So we now have a scatter plot, and in that scatter plot, we have our attack zones. We made those attack zones using some conditional filtering. If you're following along and you're like, oh, okay, I get this. Okay, this guy's cooking. Hell yeah. Good job. You're on a really good path to being a data analyst. You're on a really good path to being a data scientist, if this is all singing to you. If you're like frantically writing down notes, you're like, oh my God, this guy is so fast. Why is he talking about Luis Sessa and asking people questions that aren't related to the coding session? That's okay too. You know, this is just one of those, like, we're gonna touch a little on some of the things you could do with data. If this seems like maybe one step ahead or a couple steps ahead, you'll get there in time. There's a lot of resources out there to learn how to use Python, how to use R, how to code, how to bring in data, how to visualize data, all of those things, you know. So if you do feel like this is a little getting in the weeds for you, don't worry. You have the notebook available. If you want to go over it yourself, that's fine. If you want to ask me questions about it, you could always come on my Twitch stream and ask me in chat. That's okay too. All right, so we have this here, but now I kind of want to start making like squares, right? So an easy way to do that is using like a something called rectangle. And so I actually need to import that. So I'm going to go back up here where I loaded a bunch of stuff in, and I'm going to import something called rectangle. As you can imagine, this will allow me to plot rectangles. And that's what we want to do here. Since we're trying to recreate the heart, shadow, chase, and waist, we're ultimately trying to recreate these different rectangles. So actually, the first thing I want to, well, yeah, let's get there. So I'm not gonna bore people too much with what a rectangle should look like, because it's what it sounds like. I'm trying to make a rectangle, but if I insert some code here, this rectangle function, what I'm doing with this code is I want to put in where the rectangle starts in the bottom left corner. So I want this to start at -22 and 0.1, because it's kind of like this point right here. So I want to start it there. And then I want to make the width and the height 4.4 and 5. And then I want to fill this pixel, I want to fill this rectangle with this color. And you might be wondering, wow, that's a really specific color. I wonder what color that is. Well, I think if I did this right, I just used like a image color picker and I just tried to copy this color. So hopefully if this plots, this is gonna plot, oh, sorry. I copied the wrong line of code. Hopefully this plots, this is plot the heart. I'm gonna, I prepared. Just like I said, -558, which is half a foot, right? This is that corner here, -5.558, a little over half a foot. And then 1.83, that's that 22 inches above the ground. So that should be this point here. And then it's going to be just about a foot on both sides. And we're going to fill it with this color here. We'll worry about Z order in a bit. But if we do this, we should plot. Oh my God, it didn't work. How do I do this? Z order here too. Z order 2. Okay, that's fine. Code breaks all the time. Ah, yes. Let's call this art. I need to add the artist. Aha, here we go. And this is now a plotted box. Let's see, we can plot this box now and see if you take a look at here. This is sort of the area of where the heart is, and if you notice heart being blue, you'll see no blue dots, which is good because that means we plotted this thing correctly, right? So here's where those blue dots are. All right, the heart. And if we allow this code to run, now we have this rectangle, right? Okay. My university won't let us take Python or R classes until we finish Calc 1, 2, and 3. So I'm pretty lost, but I'm still really enjoying this session. Can't wait to learn all this stuff. Well, that's good. I hope you continue to learn it. It's a good thing to do. But yes, coding is it is instrumental to analytics departments. Usually, the requirement to get into an analytics department at this point is knowing some sort of language, computer language like R or Python. Having some database skills is also something that is good to have. Being able to write a query in SQL is pretty good. Again, Sean Lahman with some SQL stuff. That's really important to have under your belt. So, okay, so we created this rectangle. I will say, again, I've written this code before, and I am going to take all of the code I wrote and copy it and paste it here directly because I don't want to bore everyone with a bunch of copying and pasting or with a bunch of lines of code that is the same thing. But we're basically making 4 rectangles just like this, right? We're starting at the bottom left corner and then creating just the width and the height of the boxes. And hopefully it's going to look just like what I think it's going to look like. And then we're going to add all of those artists, all of those rectangles here. And now we have this. That's pretty good. That's not bad. So now we have a heart zone, a waist zone, or sorry, a chase zone, sorry, a shadow zone. And then our waist zone, and then our chase zone. And then even more pitches out here, but we'll worry about that later. So we have all of these rectangles. If I wanted to work in your department, what tech stack or skills stand up to me the most? How can I optimize my chances of a callback? By the way, awesome. Okay. So appreciate that. Thanks, Zach. The tech stack or the type of technical skills that people might want to start learning You definitely want to learn either R or Python. A lot of the time, a lot of departments aren't necessarily so picky whether it's R or Python. You inevitably in your data analyst or data science or baseball analytics career will learn both to some extent, and for a good amount of you, probably both very fluently. When it comes to database skills, we access data through a database. You might want to learn something like SQL for those who are interested in more of like the big data systems and ingestion of data process. You might want to look at something like Spark as well. But I would say the starter pack would be like R or Python and learning how to write some SQL queries. Most programs of study that are focused on, say, data science or some sort of data analytics, whether it's through a stats department, whether through a computer science department, a lot of them will have programs of study, class requirements for you to have intro to a database where you learn SQL, or intro to programming or statistical programming, where you will learn something like R or Python. So I would say check with your program of study, ask advisors if you're in school about how can I get classes, how can I put this into my program of study as I work towards graduating. I would encourage everyone to really, it took me a while. Like I wasn't a good student. I went to school for psychology. I was like involuntarily at a 2-year university for 4 years. That's how bad of a student I was. I didn't realize like you actually have like really big ownership over your program of study. Like if you want classes in and out of your program of study, usually department heads are like, yeah, that sounds great. Go on and be a data scientist, young person. So feel free to go out and take control, ownership of your path, your degree, especially if like, you have the time to go to school, learn all this stuff full time and dedicate a lot of time to growing your skills, learning new skills, especially related to like data science. I would recommend you, people of the SABR Analytics workshop, to go out and do that. That's a good thing to do. While I'm jabbering, I'm just going to clean up the graph a little. I'm going to do something called D-spine. When you D-spine something, you take out the axes. You take out like the border. So you can see there's like this big black square outline around it. If you want to clean it up, make it look a little nicer, I tend to D-spine. Take the spine. Make this a spineless graph. Left equals true and bottom equals true. That will also take out the left and the bottom lines as well. Okay. This is shaping up in the way Tom Tango intended. Okay. Let's now insert some other things like we can insert like what do we have here? We could insert, let's say, the runs. Let's actually start with the runs because data wise, we need to be able to do the runs here. So in our data set, there's actually a few columns here that they use on StatCast to get these different runs, right? And one of them is this delta run exp, which is the change in run expectancy. This is basically pitch by pitch what the value of the pitch is. If you're familiar with some of Tom Tango's research in terms of run expectancy, some of the most common run expectancy tables out there are like run expectancy 24 for the 24 different base out states. If you want to go down to the count level, that is run expectancy 288. Is that right? People in chat, is it RE288 is every base out count state? I think that's right. It's 288. Thank you, Dakota. Appreciate it, Deed. So RE288, if you think about like, oh, run expectancy in the base out count state, that's cool. What is base out count state? Well, the change in a count would be due to a pitch, right? So we're actually talking about the run expectancy per pitch now. So if we have a change in run expectancy, we're really talking about RE288 differences and also any value of an event. So whether it's a home run, whether it's a double, triple, single, a walk, a sac fly, or whatever it might be. If you are further familiar with linear weights in WOBA, you might be able to piece together your run value, your run expectancy model. But change in run expectancy, it is given to you by the league. Here is delta run exp. This is change in run expectancy. We're going to use that. And we're also going to use this thing here, bat score, which is the score of how many runs does the batting team or have. And if you're wondering, like, dang, how does he know all of these column names? Well, if you actually search at the CSV doc, shout out to everyone at Advanced Media for keeping a data dictionary, a document of all this. And if you go type in bat score, you actually see a pre-pitch bat team score. That's what it is. And you could also have that for the fielding team. And there's also a pitch score. It's somewhere up there. Believe me, trust me. And down here where it says delta run X, it actually says change in run expectancy before the pitch and after the pitch. Hot dog. Okay. So we're going to use this delta run expectancy, and we're also going to subtract, yes, the bat score. That way we get we're gonna take the bat score and we're gonna take the post bat score. We're gonna create our own delta. So rather than using the run expectancy, we're gonna create our own metric. All right, that's what we came here. Right? We're like, let's see this data guy do some data tricks. I'm gonna take the post bat score. This is the score of the score after the pitch was thrown, and we're gonna subtract it from the bat score, which, as we just read, that was the what was that? This is a post-pitch bat score, and then this was pre-pitch. So now we should just get the bat score, the delta bat score afterwards. Okay, delta bat score, y'all. So if we use this, we could probably get some sort of text to appear. So what text am I supposed to use for this? Oh crap, I actually don't want bat score. Actually, I do. Let's do this. That's fine. We're going to create, oh man, now I'm on the spot. How do I create data here? Some text. So let's take the, we're gonna look specifically for the runs in this zone. So we know a few things, right? The first thing we know is the attack zone is known as attack zone. That is a column that we have here, attack zone. The second thing is we have this bat score, and we're gonna aggregate or group by. So we're just gonna take all of the attack zones. We don't need to make this an index. And then we're going to sum up the values. So if we want to take a look at what this looks like, we could just do it in the cell above here. So here are the different bat score runs given the zone. And this seems pretty far off from what we wanted. Like the pre-pitch, post-pitch. I think it's because, like, the game might be like, 6 to 7. Now it's 7 to 8 or something. And like, we're just counting like lots of runs. So this doesn't look like what we wanted, which was -4, -4, +4, +2. So we should probably use something else. Let's try to use that delta run expectancy. Let's try to use delta run exp and see if we get closer. So we run through this, we actually do see like the heart here, negative 3.9. All right, that sounds good. Shadow, negative 4.4. Okay. Chase, this is a plus 4.516. And waste 2. That's pretty good, right? Negative 4, plus 4, plus 2. As we say on Twitch, that is poggers. Wow. Okay. I said that aloud. Okay. So we have our attack zones, the value of each of these zones. We can actually do a little more here. Okay. Sorry, I incited a pog riot inside chat. I'm sorry. I'm sorry I'm the most annoying presenter, chat. I'm actually sorry I'm the most annoying presenter. People are out there like, man, I have to sit through this guy's presentation. What a buffoon. So here we are. Now we have -4 for heart, -4 for shadow. I just rounded. I just straight up rounded these things. The chase is +5. Okay, at +4. I mean, you know, who knows how they round things at MLB Advanced Media? I don't know. I don't know how to round. I went to school for psychology. And waste +2 runs. Okay, that's good. So we're in the ballpark. That's not bad. Just to make this look a little better, as type, let's turn this into integers. That way, when we have these numbers, rather than having a float type or something with a decimal, we'll have these nice rounded numbers without decimals. All right, this is good. We're feeling good. I'm feeling good. I think this is good. Okay. I tried to explain my other programmer / data science friends how nerdy this is. Oh yeah, I try to tell the front office that this is what I do for fun. They're like, you go home and do more data science for 4 hours a night for fun, and they're like, wow, you're an animal. You're an animal. You're a wanimal. Ah, see? That's my name. That's okay. Sometimes they land. Sometimes they don't. Okay, so we have the zone and the run expectancy. I'm gonna try to just put that text in here. So I could actually like add text. All right. And if I want to add text somewhere, let's just say I'm adding like the 0. I don't know. Let's see. 3.5, 3.5, and then the text. I want to call. This is the heart. I want to call .loc df text. Oh crap! That's not how I'm supposed to do this. Df text attack zone. We're going to do that conditional filter again. We're going to look for the heart. We're going to look for the heart. So when I do this, I only bring up the row where in the column attack zone is equal to the label heart. And so now I get this row of data. Now, if I just want this number, -4, I can say, let's take a look at only delta run exp. And now this is going to give me a different type of output where this is index value 1, and this is a value of -4. I'm actually going to even go one step further and say values, and we're going to get the value -4 from this. Okay. So I'm just going to call this val, and I'm going to put that in there. I'm also going to do some other things to it. I'm going to call this in some text. I'm going to say runs. That way, this will have a number, and then the next to it will say runs. So if we run this, nothing happens because I'm horrible at coding. All right, z order equals 10. Let's see what happens here. There we go. Look, -4 runs. That's not bad. That's like Gordon Ramsay wouldn't like it, but you know, my best friend would be like, you know what, that tastes pretty good. That's not that bad. Okay. This needs to be a little lower. It needs to be in the heart area, right? And then -4 here, +4 here, +2 here. I'm not gonna lie, chat. I'm not gonna lie. Similar to other things we've done before, I may have done this already. And so rather than boring you with aesthetic changes, I'm going to actually just do it all right now. I'm just gonna do it all right now. I'm just gonna copy some code. I'm gonna put it in here. And then when we run this, it breaks because I did something bad. What did I do bad? Oh, that's right. I need this in a different format. That's fine. Don't worry. This is all according to plan. This is all according to plan. Rather than boring you with like really, really technical Python stuff, try to keep it to the baseball stuff. When we run through this, there we go. Look, now we have these things here. -4, 5, 2. Not exactly that, but remember some rounding issues. So we're able to plot sort of the onto the rectangles. Also, some of the text here. Now, if we continue doing this, if we continue doing this, we could actually like put in like home plate if we wanted to, right? There's a home plate thing here. We could make this look a little nicer in terms of the evenness of the graph. We could do all sorts of things, but I'm kind of curious. Like, we initially did Lars Newt bar. I'm kind of curious to see if I bring in Newt bar's data, how close we would get. So let's try that, and then I'll take some questions. So let's load in some Lars data. And anyone watch that movie, Lars and the Real Girl? Anyone watch that? That was a good one. So we do this, we get -6, -8, 16, and 6. We go to Lars Newt bar. Seeing it, not bad. Okay, I'll take it. Let's see what Lars Newt bar is doing. Lars 2023 NL MVP. Okay, all right, maybe. Who knows? Who knows what the future brings? -6, -8, +15, +7. -6, -8, +16, +6. That's not bad. So some rounding issues, some rounding errors here, but this scales, right? So we're able to write a bunch of code with our plot, and we're able to do a few different manipulations, not a ton, just adding attack zones in here with some conditional filtering. We don't even need this. This line of code was junk. Screw that line of code. But here, with these 5 lines of code, we're actually able, and then like a few different things for the plotting, we're actually able to recreate the stuff that they're putting out there on Baseball Savant, which makes sense since Baseball Savant's using the same data. We should be able to recreate the same data visualization. But as you're seeing here, especially if you're new to coding or new to analytics or new to data visualization, new to the field of baseball analytics in general, some of this stuff does take a little longer than you might think. So when you are out there working with your college team or your baseball team, whatever team you might be working with, and they're like, oh, like I see it on Baseball Savant, it can't take that long, right? Wrong, my friends. Sometimes it takes quite a bit of time. So just remember, some of this stuff does take a bit of time to build. Of course, I kind of set myself up for success, even though I somehow still failed at times over the course of the last a little less than an hour. But it did take a good amount of that hour for me to just copy and paste and walk through line by line some of this code. So anyway, with all that said, what do we got for questions? What do we got for questions here? Let's see. Do you mind explaining the plot, what the plot shows us, or what would help a player / coach understand? Well, for this is your swing and take graph. And really what this is showing is like the amount of value generated in these different areas. So a way that I would maybe explain this to someone in baseball would be like, you might generate value in different areas, right? And hopefully we do see a lot of positive value on the outside because you're taking those pitches and converting those pitches into walks. But the areas where we want to see people do damage in, where you should really be seeing positive values, would be places where you should swing your bat. Like for instance, the heart of the zone. Lars in 2022 with -6 runs. It sounds bad, but we should try to encourage people to maybe swing, make better swing decisions, work on things that help us create contact or create damage in that part of the zone, and try to lay off areas that maybe encourage swing, strikes, or chase, right? Like the shadow zone, maybe you're chasing a little too far out of the zone. Clearly getting a lot of value out of that chase zone. So there is some plate discipline metrics here to show. So maybe it is better quality of contact through the heart, being able to be more specific and educational with a player's player plans through a season, you know? See you later, Santiago. How often do I use calculus? Indirectly all the time, but like directly, am I like calculating like anti-derivatives and, you know, proofing out different things? Never, like the majority of the work that I do, if I'm doing data visualization, looks a lot like this. I'm like throwing stuff at the wall, trying to make it look good, working with a coach on like, hey, when we show this to people, like, does this communicate information really effectively, really quickly? And they'll tell me straight to my face, like, no, this is trash. You are trash. I'm like, oh, okay. No one's actually said that before, but sometimes I'm like, okay, this wasn't good. Let's improve on it. And then we come back and I say, hey, how about this version? I'm like, yeah, better. This tells me this and that. Can we also get something that tells me this other thing? A lot of the iterations tend to be in the visualization, the presentation of the information. Is there a GitHub repo for this? I put the link in chat. I'll do it again. I'll paste this here. Let's see. What else we got? What's something to take in my career to get to the position I am now? Like a lot of people, I just applied using Teamworks. Does everyone know about Teamworks Online? Has everyone seen Teamworks Online before? Can we get some yeses or nos in chat about Teamworks Online? Yes. Lots of people. Okay, look. Oh God. Okay. Holy. Okay. All right. For those who don't, you could actually just go to Teamworks Online. Oh God, no! Don't sign me in. Okay, cool. If you click Find a Job, this is literally what I did when in 2016. I looked at player operations. Technical services is a low-key, sneaky place to find data analytics jobs. And then search, and then you're gonna find a bunch of different jobs for a bunch of different teams. Here's one for the Penguins as a production intern. Okay, not exactly the jobs y'all might be looking for. Here's one for, okay, no, cloud engineer. There we go. Some of y'all might be, systems or data engineers. That's for the Red Sox there. So there's a lot of different jobs here. Typically in the off season is when a lot of them are a lot of teams are looking, but you can see here, like the Dodgers looking for a quantitative analyst intern. Shout out to my dude Richard Anderson. Much love, brother. So this is typically where jobs are posted, and this is where I applied. So I just applied. I can't speak too much to like how I got there in terms of my education, but I'll say that I did know Python. I knew statistics. I felt like all the things at the time I could contribute in terms of machine learning, predictive modeling. So I applied, got back a lot of interviews, and ended up with the Reds as a data scientist. I've been here since 2017 and worked my way up to director, really through just projects at the Reds. So whether it was working on the advanced report, whether it was working on database stuff, whether it was working with modeling, data visualization, just being in conversations about baseball, it all counted. And now I'm a director, but not all paths are built equally. Mine is definitely not as clean cut as I'm making it sound, but I tend to tell people like baseball is always going to be there if you want it. And if you get in, like it's up to you whether or not you want to stay there a lot of the time. That's my personal take. I think, you know, there is a lot of talent that baseball teams try to keep, but especially with technically skilled people, there's always like a bank or a startup or some tech company looking to give you a little more money for the same skills. And so it just depends on whether or not baseball is really the passion industry for you. A lot of the time, I feel, or I'm working on making that better at the Reds personally, but it tends to be that way sometimes. Any advice on creating reports on opponents, like advanced reports, advanced scouting reports? Ask your coaches what they would be interested in. That's probably my best advice. Never try to create something and then like shove it down people's throats, right? I was talking to Larissa Hedgecock over at Ohio State once, and she was like, "Hey, I'm creating this thing with the coaches. Should I keep doing this?" I'm like, oh, no. Ask coaches for feedback first, and then build something that you both want to build. Never try to do this thing just because you read it on like a blog and like it's the thing that, you know, so and so on the internet's doing, so we should do that here. Try to work with your coaches, and if that does align with their vision, their philosophies, then start promoting that in different ways rather than just presenting them a number that they're not familiar with. What were the job titles I was looking for when I started? Well, anything with the word data in it, I was applying to. But remember, this is like 2016, 2015 when I was looking for jobs. The industry has changed a lot in the last 8 years. So there are definitely not necessarily titles out there that I'm like at the entry level or the mid level that I would say would be similar or synonymous. It's so specialized now with a lot of different teams and a lot of different titles. So something along the lines of like quantitative analyst or junior data scientist is probably what I ended up coming in as at the end of the day. But I came in as a data scientist as my title. Now, if you're able to share what is one of your favorite projects your analytics team created during my time that helped the Reds improve or win, I cannot share. Here is our secret weapon that helps us. Yeah, I can't do that. But I will say I have been very privileged to. I've actually had the honor to make a lot of impactful stuff for all of our different groups here, whether it's player development or scouting, front office, player personnel decisions, player development or major league team decisions, anything that goes into the game, anything that goes into personnel. I've been really honored to be able to contribute to a lot of those avenues here at the Reds with data science, with data analytics. And so hopefully I could keep doing that for a while. Skyline, yes or no? You know, I'm kind of a fence sitter. I know it's like a either you love it or hate it. But for me, it's like yeah, I guess. Like but I usually am not the spaghetti guy. I'm like get the coney, because like a chili dog sounds a lot more normal than like uncooked shredded cheese on top of chili on top of spaghetti. Like that just sounds like good on a hot dog, just like a regular chili dog, right? Where can we learn how to do more plots like the one you showed us? I would say the best resources are probably on YouTube. But I would say if you want more specific analytics, sports analytics, baseball analytics, tutorials, not to pat myself on my own back here, but my stream is pretty good. Also, my YouTube channel, I do post, or I'm trying to post more regularly, tutorial stuff. That's youtube.com/Nick Wan. I'll take one more question. Let me find one more. On the topic of jobs in sports, is much of the back off support in sports field work require remote, hybrid, or required in-person capacity? That at the Reds, we do all of that. So my analytics team is actually majority remote. And then we also have someone who works out of our spring training complex here in Goodyear, Arizona. And then we have about 4 or 5 people who are in Cincinnati who relocated from where they were living before. So there's a big mix. I personally, in data science, data analytics, I don't think it's necessarily a huge issue, but there are some things where in person it would help a little more. There are just conversations that happen in other departments that are all in person that, you know, if you're around for, those are typically only had in person. You're not getting on a random Zoom and inviting everyone to it, you know. So there are some benefits of being in person, but in terms of doing your work, your responsibilities, I think a lot of it can be done remote. Anyway, appreciate SABR, Scott, and Scott for having me. It was a blast. Hope to do it again next year, and I'll see y'all in person at SABR Analytics this year. And for some of you, I'll see you in like 2 hours with Tyrone on the porch here. But thanks, y'all.
Nick, you are the man. We really appreciate you being with us, and hopefully everybody got a lot out of Nick's presentation. Certainly one of the more relatable guests that we have in the entire conference, and we're glad to have him every year. So what we're going to do now is we're going to take a longer break. So this is going to be almost an hour break, give everybody a chance to grab some food, decompress a little bit, and then when we come back, we're going to turn everybody's videos on, we're going to turn your mics on, we're going to give you a chance to talk to each other and build your networks a little bit, and have a networking session amongst students, which is always a lot of fun. So we'll be back at 5 o'clock Mountain Time. So we'll see you then. Thanks, everybody.